Hi, folks. This is my February installment of climate change updates for the environmental century. I've been reading Greta Thunberg's edited volume, The Climate Book, and I have to say it is really excellent. It's got some of the world's leading experts in various fields. Sometimes they surprise me with some of the things they say, or actually, I disagree with some of the things they say. But nonetheless, it is a really powerhouse compendium of authors from various walks. A lot of great science is reviewed. Each author spends no more than about 1 or 2 pages reviewing the basics. And Greta's commentaries are spot on. They are actually very current with the science, and it's amazing that I'm teaching college students, and I think she might be a sophomore at university right now, but her understanding and expertise is equivalent to that of any graduate student I've ever talked to about climate change. So it's really worth your time if you'll take a look. One of the things that stands out to me in this book is this vast disconnect between what the United Nations emissions reporting is and what the emissions actually are. So what I'd like to do is review what I call lies, damned lies, and omissions of emissions. And let me share my screen, and we can begin. So lies, damned lies, and omissions of emissions. Of course, lies, damned lies, and statistics is a quote from Samuel Clemens, Mark Twain, and its original provenance is in dispute, but we'll credit Mark Twain with that quote. And what I'd really like to talk about today are how the emissions that are actually being elaborated from the planet Earth into our troposphere and by us don't match up with what the United Nations is using in their reporting schedules and in their projections. I always like to start by looking at the amount of CO2 in the air today, and you can see the annual cycle. We're in the midst of winter right now. Uh, Presently, for the week of February 12th, it's 420.77 parts per million. The weekly value from a year ago was 419.62. And the weekly value from 10 years ago was 397.32. I calibrated my first infrared gas analyzer at 323 parts per million in 1980. So the last time the concentration of CO2 exceeded 400 parts per million was 3 to 4 million years ago. And the current rate of emissions is 200 times faster than the estimated rate during the end Permian extinction, when a massive volcanic extrusion onto the surface, known as the Siberian traps, produced enormous amounts of carbon dioxide and other greenhouse gases, mainly methane, into the atmosphere and warmed the atmosphere and acidified the oceans. 96% of all marine species went extinct, and 70-some% of all terrestrial species went extinct at that time. So if you think that we can be adding this much carbon dioxide to the atmosphere in this short of a time frame and it not have a major effect on the Earth system, I think you're probably very poorly informed at best. So the Climate Action Tracker is the group that I'd like to focus on. They're considered to be the authority on what temperature targets we might achieve with various reductions. And you can see that a variety of different reduction scenarios could take us below 2 degrees Celsius, but not quite to 1.5. According to the Climate Action Tracker, we're at 1.2 degrees C warming, and all of these temperatures are relative to pre-industrial, which the IPCC now uses as 1850 to the year 1900. So Berkeley Earth says we're at 1.3, but it uses a slightly different starting point. So the question is, how trustworthy are these estimates? Do these data include all sources of emissions? And I'd like you to show you in the next few minutes that they do not, and that this is very much a concern. Another group called carbonmonitor.org for February 18, 2023, produced this particular graph, which shows global emissions from fossil fuels and cement production. And this is the typical uh, assessment that is done by the United Nations and by the Climate Action Tracker, fossil fuels and cement production. And you can see in 2020, there was a lower overall rate of emissions throughout the year. And this is largely due to the impact of COVID-19. The zero line in the left-hand graph represents 2019 emissions, and then the various other components represent the difference in 2020. And you can see it goes negative for power production, ground transportation, shipping and industry and aviation. Interestingly enough, with a lot of people staying home, the residential use of emissions of CO2 went up. You can see on the right-hand graph the various countries and their emissions. Both China and the United States had major emissions from ground transportation that went negative during the lockdown. But what about land use? Land use change, forests, and other positive amplifications of carbon dioxide in the atmosphere. These things are not reflected in the overall United Nations accounting or in the Climate Action Tracker accounting. And so, problem number one is the burning of wood for power. This is the European Union's big omissions from their emissions accounting. The Kyoto Protocol, largely through an accident, decided that wood was a renewable energy. And therefore, the European Union and many other countries have adopted this standard and thus omit biomass energy, or wood, burning of wood in particular, from their emissions summaries that they submit to the United Nations. So trees take up CO2 and release oxygen, but we harvest those trees in various forms and we ship them to biomass power plants, many of which are in Europe, and we burn them for energy production. The European Union has bet big on this, billions of dollars, and they've invested huge infrastructure in burning wood. It's an irony that this takes us back to before the steam engine, back in the 1700s, the 18th century, when most energy was derived from wood and from animal energy. This is the European Union use of biomass for energy, and you can see it continues to go up. This is very alarming given the fact that this biomass is largely in the form of wood, and it's not accounted for, excuse me, it's not accounted for in their emissions accounting that is submitted to the United Nations. So the weak link in all of this is the uptake of CO2 from regrowth forests. So we burn the wood products in a very short period of time, and then we replant the forests or we continue to grow forests. And the argument is that this will fix or take up the CO2 that was released. Well, there have been a number of damning headlines that have appeared in the mainstream media and other sources. This is The Guardian in 5 of September 2022, where Greta Thunberg and others said burning of forests for energy isn't renewable. Now the European Union must admit it. And this is the run-up to a big meeting of the EU where the standards for renewable energy were being reconsidered. Prior to that meeting, also the New York Times did a in-depth study of Europe and its use of its ancient forests for energy, primarily in Romania, is where this study focused. And it is truly alarming the amount of ancient forest and ancient wood, excuse me, that is being used for power production in Europe. Bay reported after the meeting on the 16th of September, the European Union votes to keep woody biomass as a renewable energy and ignores the climate risk. The Guardian put it a little more nuanced and said it limits subsidies for burning trees under renewable energy directive, but it did not phase out wood as a renewable energy source. So, because of the lag between emissions and uptake, analyses of this approach often find that widespread use of wood fuel will cause emission spikes that could last for decades, hastening the pace of warming. We don't have time for this. Pellets for burning in power plants could come from waste wood, could come from old growth, or it could come from plantations. And if we look at where in the United States wood pellets are being exported to Europe from the southeast, we see that there are several locations and various ports where wood pellets are loaded into barges and shipped across the Atlantic. This is an image of whole logs at the Enviva wood processing factory in Garysburg, North Carolina. And you can see these are likely plantation logs because of their uniform size, probably longleaf pine. And here's an example of the pellets that are created and then shipped to power plants. I would point out that using waste wood does not obviate the damage done from burning wood, the emissions from burning wood. And this is because waste wood, although it will eventually find its way into the atmosphere, doesn't happen on the same time scale. It doesn't emit into the atmosphere on the same time scale as burning it in a power plant would. And in fact, the time scale could be like an hour, however long it takes to burn it in a field as waste wood, or up to a couple of 100 years or longer if it's allowed to lay fallow and rot. So saying that waste wood obviates the concern is really quite specious, in my opinion. Harvesting of old growth is unconscionable, and plantations perhaps could work if, in fact, the carbon balance of uptake is equivalent to the rate at which they are burned in the time period. But in point of fact, burning wood releases less energy per unit mass than does burning coal. And in fact, we see the biomass of whole trees, 70% whole trees in this graph, which is not atypical for a lot of power plants, especially if the trees are coming from plantations. And you see there's a spike. And again, I would submit that we don't have time for regrowing the trees to eventually absorb that carbon dioxide. Here's the woody biomass by county in the United States from a 2014 census. You can see there's quite a bit along the East Coast and the South, and a lot on the West Coast. A full accounting of carbon loss from deforestation must include an impact on above and below ground ecosystems, and the opportunity cost of removing the source of photosynthesis drawdown of CO2. So if we take 2050 as a putative target date, the carbon gain from leaving the forest intact is shown by the green dashed wedge, and the carbon loss directly from harvest, which is what is usually reported, and then the carbon loss from less readily observed degradation processes following forest clearance. This includes stuff below ground, like mycorrhizal communities and detritivore and detritus that exist below ground, the carbon cycling of the soil, and all of the above ground and below ground ecosystem that is supported by the carbon that's being pulled out of the air and then shipped down the trunk of the tree into the soil to nourish the ecosystem below ground and then eventually ecosystems above ground. So there's anytime you cut down a bunch of trees, you're not just cutting down the wood, you're damaging entire ecosystems. The total carbon impact of forest loss from clear cutting could be over 600% higher than considering just the direct impact of the harvest. So Bloomberg in winter 2020 had this cover of its magazine, Money That Grows on Trees. And the concept for using forests for carbon credits is very simple. You sequester carbon by growing trees, or you avoid cutting down those trees and thus avoid releasing that carbon, which allows a crediting agency, usually a private enterprise, to sell carbon credits to a carbon emitter. Well, this is bullshit. And the reason it's bullshit is because of the heterogeneity of natural ecosystems, both above and below ground, in time and space. This heterogeneity is very difficult to account for. And so quantifying those carbon credits is very problematic. So, problem number two is false accounting of carbon offsets from the forests. There are a number of ways that forest-based natural climate solutions can encounter pitfalls. One is crediting actions. You could credit actions that would have occurred anyway. This results in errors in carbon baselines. The other is there could be leakage, largely due to economic drivers. The University of Florida offset its homecoming game several years ago by purchasing the rights to forestry for a big chunk of real estate in North Florida. Well, all this did was drive the market for that timber elsewhere, and that's a form of leakage. Non-permanent. Forest fires, bark beetles, loss of ecosystem carbon due to climate change itself or due to direct human actions. And then net warming, change in the surface of the landscape changes the biophysical feedbacks, which can cause carbon storage to not offset the warming effect caused by those changes. There has been massive overcrediting in forest carbon offsets. Overcrediting in forest carbon offsets is very common, partly because the regions that are claimed for offsets are often heterogeneous with different ecosystems that have contrasting carbon uptake capacity in time and space. So landowners and timber companies claim an entire region as having the same potential as most usually its most productive regions. State and federal regulators often accept these estimates. The California Air Quality Board, the CARB, Air Resources Board, the CARB, I think is the acronym, accepts those estimates and without question, and incorrectly so. The figure on the right shows the Southern Cascades supersection, in which the carbon potential from many samples of Douglas fir forest, which has good drawdown capacity, is applied to the entire region, including drier regions where ponderosa pines grow, and they don't have the same drawdown capacity. Overcrediting in forest carbon offsets can happen temporally. So in the initial crediting calculations, the baseline is set, and then that's relative to the common practice of how the baseline is set. And then upfront credits are awarded. Overcrediting occurs when that baseline shifts for a variety of reasons. A new common practice emerges, or the forest itself changes. So spatial overcrediting occurs because of spatial averaging of forests with disparate carbon storage capacity, and temporal overcrediting occurs because of changes in carbon storage capacity that do not match those derived from sampling efforts relative to regional carbon storage capacity. Most offsets for rainforests are utter garbage. This is something that many of us who have worked in tropical forest have long suspected, and a number of crediting systems looking at the United Nations program known as RED and RED Plus have actually demonstrated that it's very, very difficult to demonstrate the value of those carbon credits. A recent study by investigative journalists and scientists showed that more than 90% of rainforest carbon offsets by the biggest certifier, Verra, are worthless. 94.9% of the carbon credits claimed relative to 5.5 million carbon credit reductions. This is published by Patrick Greenfield in The Guardian on the 18th of January of this year. Major companies claiming these offsets through the Verra carbon standard are Netflix, Ben & Jerry's, Shell, Gucci, major airlines, other major oil companies, and many, many more. CAT, or the Climate Action Tracker, uses a good practice scheme for assessing targets and actions by different countries. It looks at the scope of those actions, the structure of those actions, and how transparent the accounting system is. So all sectors and gases are covered in the scope. Net zero target fully covers emissions from things like international aviation and shipping, and it reaches net zero within its own borders. The architecture or structure is legally binding within a country. Separate targets for emissions reductions and removals, legally binding review of target and progress against it at regular intervals. This is the review process. Separate targets for emissions reductions and removals are absolutely essential to separate those two so that they are not confounded, especially through the use of natural climate solutions like forests. Transparency, transparent and scientifically robust assumptions that can be verified, transparent and scientifically robust pathway, and clear measures for achieving net zero, and a clear statement on why the particular target is fair for that country relative to other countries and their obligations. Well, just prior to the Glasgow conference, the rating system for targets and actions showed that the net zero target design was vastly inadequate at that point. And the Glasgow conference, although it claimed to make progress, still has not really changed these percentages. Acceptable is not the same thing as meeting the targets. Chile and Costa Rica, the EU and the UK have what are considered to be acceptable targets for net zero. The average for Canada, Germany, South Korea, and the US, about 17%. Most countries assessed were poor. And if we add no target plus pending plus information incomplete, the majority of countries simply don't weigh in. So we're simply not on the map in terms of where we need to be in terms of the emissions reductions that have to take place. The CAT acknowledges this, and they produce their own version of the United Nations gap report. And this is the emissions gap by 2030. You can see the target gap and then the implementation gap to reach 1.5, which is the ideal temperature rise that we would like to stay at or below relative to pre-industrial. But the Climate Action Tracker acknowledges that estimating national emissions in their system and in the United Nations, which they largely accept, does not include land use change, and forestry. They say, quote, the CAT methodology for assessing and rating climate action and targets focuses on CO2 and other greenhouse gas emissions from fossil fuel combustion, industry, agriculture, and waste sources, but which accounts for 93% of global greenhouse gas emissions, but their inventory year is 2010. That's 13 years ago now, or almost. CO2 and other greenhouse gas emissions from land use change, and forestry, which account for um, around 7% of global greenhouse gas emissions, are not included in the effort sharing rating system. The rationale for generally accepting the UN estimates of emissions are as follows. Fossil emissions are the most important. No argument there. That is true. There's large uncertainty in sources of land use change, and forestry data. That certainly is true. The need to compare the nationally determined contributions from each country using a common, transparent framework, of course, that's a no-brainer. Challenging methodology make land use change, and forestry hard to estimate over time and space. We've just demonstrated that. But is this an acceptable rationale for using an old inventory from 2010 and for not accounting for the emissions from the biological portion of the planet or the net flux of those emissions? There's both uptake and release. Well, the most important observation here is that the UN pledges and promises are actually built on flawed data about nature-based uptake. So the countries underreporting emissions are relying on flawed measures of uptake by forest and other land systems to offset their fossil emissions. In other words, they've already rolled these offsets into their reporting to the United Nations. And that is, in fact, the case with the European Union, as I just talked about. The accounting system has resulted in huge overestimates of pledges' positive effect and promises made during the Conference of the Parties 26 in Glasgow in November of 2021. 8.5 to 13.3 billion tons are underreported. The gap is mostly in carbon dioxide, and it is huge. Well, if you add to this the carbon bombs that include plans to massively expand liquefied natural gas, which I prefer to call fossil gas capacity, you can see that the International Energy Administration in 2022, their net zero scenario line is in orange here. Under construction and approved LNG facilities and then proposed would take us far out of reach from that net zero scenario. This is mindless whistling past the graveyard, as near as I can tell. The United Nations process has no credibility at this point. The outcomes of the COPs have been repeated failures to address the central problem of fossil emissions. Next year's COP28 will be held in Dubai, the showcase city of one of the major petrostates of the world. And its leadership has been appointed to be Dr. Sultan Al Jaber, the chief executive of one of the world's largest oil companies of the UAE. And this is a very telling statement about just how serious the United Nations Conference of the Parties process is about saving a future for our kids in college today and their kids and their descendants. So here are 10 basic facts for human and planetary survival I'd like to leave you with. On the physical and natural technological sphere, climate and ecological crises are really, really bad. Our current trajectory, with our current trajectory, they will become much, much worse. We can still, right now, prevent the climate and ecological crises from worsening. This will require radical change, reducing the scale of consumption. This radical change is compatible with universal human well-being and healthier societies. If we look at social, economic, and cultural and political processes, our economies and governments are responsible for these crises, and they perpetuate them. We should expect economically powerful forces to maintain our current disastrous trajectory. This is what we've seen over and over again. But we, the people, do have the power to be a necessary counterforce to fossil fuel industries and their corruption. But we have to act collectively. We must do this ourselves, working together collectively. No one else will save us. I had a student ask me the other day, so how are we going to get out of this? Well, the answer is all of us. We are all that stands between our world and its the destruction of civilization. As engaged activists, we must build resilient, equitable, and just societies within planetary boundaries. And as always, you can reach me at smulkey@ufl.edu. I'm happy to take your questions and concerns and corrections. Be well, everybody.